Welcome to our podcast review here for chapters 6.1 through 6.3, and then we actually jump to 6.6. So as we go through here, make sure you have your study guide ready, pen or pencil, and we're off. Going to start here with our rotation versus revolution posters. So go to that section. First question, how long does Earth take to revolve? Remember, revolution is the actual movement of one object around another. Gives us a year, so it's going to take 365 1/4 days. What causes the constellations to appear to move? And that's going to be, as we revolve around the sun, we have different views of the stars, and then also as we rotate, those constellations also are going to appear to move. So it's the revolution and also the rotation. And we can see the rotation moving the stars, especially those that are around Polaris, our North Star. So those constellations are going to be good proof of our rotation. And then the ones that are more towards the southern sky are going to change throughout the year because of our revolution. How long does Earth take to rotate? It's going to be about 24 hours. It's just slightly shy of that, but we round that up for ease. What causes night and day? That's going to be Earth's rotation on its axis, so the spinning on its axis. What causes the sun and moon to move across the sky? And that again is going to be Earth's rotation on its axis. 'Tis the season is up next. Why does Earth have seasons? Two things, its tilted axis and its revolution. So the tilted axis that Earth has plus the revolution is what creates our seasons. What occurs when neither hemisphere is pointed towards or away? So we've talked about this previously. It's equal. So we're going to talk about the equinox. And you can see the E, Q, U, equal, and equinox. What month is or are, or months, the southern hemisphere in winter, and why? Well, they're going to be in winter from June to September because they're tilted away from the sun. Remember, whatever the southern hemisphere has is the opposite of what we have. So we have summer during these months, they're going to have winter. And it all comes from the tilt of Earth's axis. Where do the direct and indirect sun rays strike Earth in each season? And we're going to use this picture here, so go ahead and pause it and you can kind of read through. I'm not going to read through everything here, but you can see the axis is here. So you can see the tilt. You can see the southern hemisphere is towards, northern hemisphere is away. So again, use the axis here to see this is pointed towards. You can see the direct rays here are hitting the southern hemisphere because they're tilted towards. So in December, it's going to be winter for the north and summer in the south. These are going to be equal. Remember, everything rotates counterclockwise in space, so we're going to head this direction. Over here, you can see June, you can see the months match up, and then back to September. Gravity and motion. What causes all objects to be attracted to each other? It's going to be the force of gravity. What does the strength of gravity depend on? Two things here. It's going to be the mass of the object and the distance between them. So we have some fairly massive objects in the universe. Their gravity doesn't affect us because they're way too far away. But then we also have some objects that are very close. You know, all objects have gravity. We have gravity, but our mass is not great enough that force isn't going to do anything, even though we're very close to each other. So both of them in tandem have to work. Inertia is the tendency of a moving object to continue moving in a straight line or a stationary object to remain in place. Talk about the Kleenex box in a vehicle. When you stop, or anything that's not buckled down in a vehicle and stop quickly, they're going to continue going in that straight line. Your book is going to continue to sit on your desk until you act upon it. Two factors that keep Earth in its orbit. It's going to be gravity and inertia. So these two in combo are going to keep it there. Gravity is going to pull it towards. Inertia is going to keep it moving away. So you think of the Earth as it revolves around the sun, the Earth as it revolves around the sun, we don't head out into space because the sun's gravity is pulling us towards it, and we don't head into the sun because our inertia, the fact that we want to continue moving in a straight line, wants to keep us going out. So those two in combination keep us in an orbit. It's not a perfectly orbit, as we've talked about, as far as shape, but it is something that is pretty common as we move around. What does Newton's law of universal gravitation state? Every object in the universe attracts every other object. Moon versus Earth. What formed because of the ancient lava flows on the moon? That's going to be the Maria. What NASA program sent men to the moon? Apollo. Remember some of the videos we took a look at earlier in the week. What name did Galileo give to the moon's surface that is covered with round pits? Those are craters. Galileo was very forward-thinking, very intelligent, pretty amazing, some of the things that he was able to come up with, the technology at the time. Why does the temperature of the moon's surface vary or change so much between day and night? It's extremely warm during the day and extremely cold at night. It's because the moon has no atmosphere. It's kind of an atmosphere can kind of be looked at as kind of an invisible blanket that really helps to hold in heat, and it's lacking that. Constellations, real quick, real simple. What's a pattern or group of stars? Constellations. These are your textbook pages. Always great to do. A little practice. And this is the end of the podcast review for Chapter 6.1 to 6.3 and 6.6 quiz. Best of luck.